and then we start having what we call network connection. But after we have network connection, other types of sharing technology comes up. We have what used to be called parallel computing, okay? And then we begin to have what is called grid computing. All these are basically technologies that helps computers to share resources within themselves. So in the case of grid computing, basically you can be able to utilize idle systems. So for example, in this lab, how many computers we have? We have maybe around 30 computers, right? Now, if you are going to calculate how much time these systems are utilized, you realize that they are more idle than useful. Do you understand? But then this is where the idea comes up. You have to find a way to use them, right? Since we spend a lot of money to buy all these systems. The most useful part of computer, of course, has to do with the storage and the computing capacity. That's the processor. Now, if you look at it again, there's actually some other organizations that have large amount of processing jobs or tasks for which they need more computing power to be able to execute it within a short period of time. A good example is GIS organizations that deals with real-time capturing of images of all the different sections of the world. So if the satellites have to capture the images in order to keep, for example, the Waze or the Google Map updated, it takes a lot of processing power to capture these images on real time and process them and still make them available to people that want to have access to the maps, right?
To have
So-
a good resolution, you mean to close that?
Yeah,
To have a good, so the Google will be capturing a lot of times and maybe in 1 second,
exactly.
just to keep the image is in a perfect way.
Exactly. So if you have such a company, you will need huge amount of processing power, and at the same time, you will need also huge amount of storage capacity to be able to process and keep these images intact. Okay. Another one that can easily comes to mind is the gaming companies. Okay, streaming companies also. Streaming companies like the YouTube. All these they need actually huge amount of processing power to be able to compute lot of videos and still make them available to users. So in the case of grid computing, the idea now comes up. What happened to all the idle computers that we have around the world which are not actually used? Do you understand? They are not actually used. They are more idle than used. A good example is the systems that we have here. Okay, so it is simply an idea for which there is to be what is called like a globus. The globus is basically the software that helps users to be able to connect with other idle computers, okay, within the reach of the globus and still be able to use the processing power of these computers, okay, in order to execute jobs that requires more computing power. So basically, the Globers will be able to connect with idle computers and use the processing power or the processors of these computers to execute jobs. And once these jobs are executed, it will be returned to the Globers, and then it will be put together, and then it will be simply be displayed or useful for the company. So the general idea is that we want to now utilize more of the computers that are mostly not used. Okay? If you have 100 computers in your company, let's say 1,000 computers in your company, and you find out that most of these are useful in most of the time, but then you have a job that requires more processing power or more storage power, you can use the idea of a grid, and the grid will be able to distribute the job to the various processors. Okay, it will execute them at a time when they are more idle. It will make them useful, and once the job is executed, it will be returned back to the Globers, and then the job will be complete within shorter period of time. So that's the general idea of a grid. Now, after the grid is actually a free service, basically. Once you are able to configure your systems on the Globers, you'll be able to use it. Okay? So it was after the grid, the idea of cloud computing comes in. Now, cloud computing try to say that we cannot make this service to be free. Okay? So cloud computing tried to add to the idea of grid, but then it's not a free service. It's an on-demand service. Okay, if you need more processing power, you go to the cloud. If you need more storage power, you go to the cloud. And then these services will be given to you, and then you can execute, or you can get more processing power or network service or a server or something like that. And once you execute it, once the cloud executed, it can give you the results. Okay, so the idea of a cloud is if you need 1 tera, you get 1 tera. How much time do you use 1 tera? You use it for 1 hour, you pay for 1 hour. Okay, so that's the idea. But then the concept is still based on that general idea of a grid, except that instead of using idle computers, in this case, the cloud create what is called cloud data center and distribute them around the world. And then the job can be basically distributed according to the data centers or servers, as we've seen in the slides previously. Okay, and then if these jobs are executed, it will be returned to you that actually send the jobs. Okay, if you need more processing power, you get it in cloud. Okay, that's the processor. If you need more storage, you get it in cloud. So now we move from single systems to network systems to parallel systems to grid systems, and now we're in the cloud, right? Well, the cloud started as far back as 2013. Then after that, we actually have more technologies that also try to leverage on these ideas of cloud computing to create something new, okay, to users and
So
make
what
it
you
more
say,
useful. No.
it was a great computer before it became cloud. Am I
Yes,
right?
yes,
So they are just like enhance the great computer to become a cloud. They are adding more future
yeah,
and more work on it.
yeah. The general architecture and the idea
The
behind,
great computer.
yes, yes, great computer.
Okay.
So then, after we move to cloud, now I'm still not really introduced this chapter yet, okay? This chapter is trying to tell us about more ideas that comes and leverage on the idea of cloud. That's why we say the trends. From cloud computing, where are we heading to? We are lucky we've seen the evolution from a single system to parallel systems, distributed system, grid computing systems. We're in cloud age, and then from cloud age, where exactly are we heading to? Okay, now these are the trends. There are more trends that comes out after cloud. So this is basically the general idea. So you have been previously introduced to how visualization technology basically integrated data center resources for better visualization. Of course, cloud computing also tried to introduce and integrate the idea of visualization. Okay, visualization, as we've seen, basically is trying to use virtual machines and virtual systems to be able to provide more computing power and more computing resources to users. Okay, so this same idea is still what the cloud actually try to add to it after mm, after it's been moved to grid system. Okay, so if you talk about cloud computing, you will hear the word scheduling will also be coming up a lot. And that's the reason why you still have to go back and understand how scheduling works in operating system. Okay, because also cloud actually uses scheduling. Now, why do we need scheduling in cloud? The general idea of scheduling is I have a job, I want to execute this job, but then I need to keep it, I need to put it, or I need to split it. In the case of a cloud or grid system, I need to split it into numerous different systems that I have to execute for me. And once they are done, they send it back. But now these systems can only handle one job at a time. Okay? Of course, even machines, they actually execute one job at a time. Okay? The idea of multitasking, as it were, it is actually still single tasking. The only difference is that processors are used at a schedule. Okay, so for example, if you have two processors and you have one job, you want these two processors to basically execute this job. This job will be splitted, of course, into these multiple tasks or jobs and then send them to these processors. Depending on the type of algorithm, first come, first serve, last jump, and stuff like that. So these processors will handle these jobs and execute them. When they finish, they send it back and it becomes one. Okay. If you are using a single system, okay, or a single processor to execute is multiple jobs. So that is to say you have three jobs, but then you have one processor. And then now you want this processor to execute these jobs on real time without any of them suffering. For example, I'm playing music, at the same time I'm streaming football match, and at the same time I'm typing on Microsoft Word. But actually I have only one processor. Now the idea is how do the processor handles all this without interrupting anyone? As far as I'm concerned, the processor is multitasking, right? But in actual sense, it actually schedules these jobs. But because this processor has a good speed, it jumps from one, it moves from your browser to Microsoft Word and to YouTube, okay, for example, and then back, and then back. But because it's doing it with great speed, you will not realize. You understand? So, but in actual sense, the processor is only doing one job at a time. But because it's doing it great with great speed, we said that the processor is what? Multitasking. The reason why the processor is able to give us this illusion of multitasking because the jobs are actually scheduled accordingly. Okay, now that is how also cloud computing works. Cloud computing have great power. the data centers and great processing capacity, and it has the ability to be able to handle billions of jobs sent by different people at a time. Do you understand? So if you are on Google Drive, I'm on Google Drive, another person is on Google Drive. Actually, most likely we are using the same processing device to do this. But because the data center is so powerful and so big, it can be able to handle all this processing.
We thought that it's in the same time, but in the real world, inside the processor, no, the processor itself is scheduled who's the first, who's the second. But
Yes.
because of its very great speed,
Yes.
so the end user will not
know.
Will not realize.
Exactly. So this is another idea that the cloud is actually using. So basically, this all comes as a result of these different technologies that we mentioned: networking, scheduling, visualization. All of them you need to understand them. Operating system. Okay, you need to understand all of them for you to be able to understand actually, if we move to the cloud, how big it handles the same concepts. Do you understand? So basically, this is the idea.
Professor, I think we have here Microsoft Cloud in Qatar.
Yes.
Am I right?
Yes, there is.
Sir? They open an office.
Microsoft.
Also
Yeah.
for the companies.
For companies.
2 years, I think, the first 2 years are free.
Exactly.
Let's go.
So let's look at the basic concepts. Okay, basic concept and component is one of the things, and the architecture of what we call OpenStack. Okay, I will explain what OpenStack is. The basic concept of edge computing. So basically, these are technologies coming out from the cloud service. So basically, we have OpenStack and edge computing, and then blockchain technology. All these are technologies coming out from the native clouds. So at the end of this chapter, we hope that you will be able to understand the concept of OpenStack, edge computing, blockchain technology, and native clouds or cloud natives and their applications. So let's start with the first one, OpenStack. So what is OpenStack? OpenStack is just a software. Okay. Now the issue is we want cloud services because now we understand how important it is. Okay. But then we probably are not that advanced to be able to develop a cloud service from the scratch, right? So we may need to have like an application software that will help us to be able to create all the cloud services that we need and be able to as well manage them. Okay, so the OpenStack is nothing but a software that can help you to be able to create a cloud environment and also to be able to manage whatever aspect of cloud that you are able to create. Even though it may not give you all the services at once, because of the way the OpenStack basically tried to design the different sections. I mean, the different section for infrastructure as a service, they create a section and then they create different components under that. And then for platform as a service, also they create section and create different components under that. And also for software as a service. So, but the general idea is OpenStack is a cloud software that helps you to be able to create cloud environment and be able to manage cloud services.
So which one from these options, Professor, is we consider OpenStack? Is it like infrastructure as a service or a platform as a service? Infrastructure as a service, am I right? Because you said that we can create our own
cloud service. Yes.
So that means
so if you want to basically place OpenStack also into the cloud services, I will say yes, it may probably be more like software as a service, simply because, no, not software as a service, infrastructure as a service, simply because it's supposed to be a software as a service, but unfortunately it's open source. So because it's open source, I will not consider it to be a software as a service. If it is provided to the cloud users, okay, and the cloud users are using it to pay, okay, then we can consider it to be like software as a service. Okay, software as a service. I need a software. I need to use it for a period of time. I pay for it, and I can go for a software as a service. Okay, so basically, this is it. So for the OpenStack, it's actually a free software, and it's open source. Okay, and you can use it to create both public and private clouds. You can construct and manage public and private clouds with this. So OpenStack is a solution for cloud platform development. Simple, nothing more than that. Okay, I need a cloud. I don't know how to build it from scratch. You come to OpenStack, and then you can be able to start something with it. It can create for you the cloud services. So this is how it is. Number one is open, because remain open source and reuse as many existing open source projects as possible. No reinvention of the wheel, because already it's designed based on an existing technology. Secondly is flexible. So this is one. This is one is open. Two is flexible. Three is scalable. So it's flexible because it does not use any replaceable component that is private or commercial, and is designed and implements architectures using plugins. So basically, you only need plugins to be able to design your architecture. So the OpenStack have all these plugins. You just simply need to use them. Then this is scalable because multiple independent projects can run at the same time, and multiple independent services and components can as well be used, and it's decentralized architecture. And something is missing here, stateless something. So basically, these are the main ideas of the OpenStack. It's open source, it's flexible, and it's scalable. So these are the different project layering in OpenStack. Okay, when you talk about infrastructure as a service, it has what is called infrastructure as a service plus services, under which we have what is called Trove, Sahara, and Suite. And of course, there are many more. Under system management and automation, there's what we call Celometer Heat. Okay, under infrastructure as a service, there's Nova, Glance, Cylinder, Neutron, Ironic. All these are different plugins in the project that we can use. Okay, then for the usage of OpenStack to be able to create and manage public cloud, it has features for database, for Keystone, and for message queuing. Now, to understand this better, we need to go back to the OpenStack website. So basically, this is the website. Let me see if I go back to the, yeah, so this is the homepage of the OpenStack. It's the most widely developed open source cloud software in the world. That's what they say. Okay, so in it you will be able to see different trends of cloud services like Cabinet, Cloud Foundry, Terra Platform, OpenStack, SDK, and Horizon Web UI. So you can see that it's also on premises, public cloud. It has the edge computing basically. Okay. So, but if you want to have a better idea of how it works, you need to browse the OpenStack components. That's the one we have in the slides. Okay. So for computing, the Nova, the Zone, Nova is basically computing services, and the Zone is container services. Okay, container service. Then in terms of the hardware life cycle, it have the Ironic, the Cyborg. In terms of storage, it has plugins such as Swift, Cinder. Actually, they just try to create names from some animals and assign to the different components of uh, of the OpenStack, basically. So the Swift is basically for object storage. The Cinder is for block storage. The Manila is for shared file system. Okay. In terms of networking plugins, they have the Neutron for networking, uh, Octavia for load balancing, and Designate for DNS services. So if you go back to our slides, you will actually see all these names here. Okay. Nova, Glance, Cylinder, and Neutron, Ironic. We can see. If you want to see the full meaning of what they means, like Neutron is for networking. Where is Nova? Nova is here. Nova for compute services. So you can see the different components, basically. So there are plugins they have, depending on the type of services you are trying to create and manage to be used as a cloud service. So this is your platform, basically, that you can. So these are the services. They have operation poolings, add-ons, and integration enablers. So all these are available on this. And then they have clients.
Are we going to have a lab on creating a virtual environment?
I myself have not used this particular one.
Yeah,
Yeah, but I will try to explore it and see.
yeah,
If
okay.
it works, I'll create for you a lab.
Yeah.
Client tools, they have development tools also. Development tools, these are development tools. And then sample configurations. So these are samples of the configurations, how you can configure. Yeah, these are samples for the Nova, Glance, Keystone, Placement, and Neutron for the networks. So this is how the website look like. So I'll go back to the slides. Yeah, so logical relationship in OpenStack core services. So all the services that we've shown in the website, they have a relationship. Okay, and this is the diagram that showed the relationship. If you create a virtual machine and you want to do some networking stuff, you go to the Nova and the Neutron. The Nova provides for you compute services like this. So these are the relationship, how they work together. So that's the end of the software called OpenStack. So this like another trend from the cloud services. So we go to the next one, which is edge computing. Edge computing is actually an idea that try to solve a major issue in clouds, which actually is not really a major, okay? But it's a way of optimizing the cloud service more and make it more useful and more secure to the users, and of course, more optimized in terms of performance. Okay, so now this is how the cloud works. I have a job I want to execute. I log into Amazon Cloud, for example. I borrow computing power, let's say processor, and I submit my jobs. Okay, if I submit my jobs, it executes this job. Okay, once it executes this job, it sends it back to me. Now, for me to be able to connect and be able to perform this job execution, I have to go through um, basically the cloud interface, okay, to submit this job to the cloud facility, and then I get it back. Now, let's take another example. Another example is we have um, we have very sensitive devices these days, like the IoT devices, whereby the idea of a delay may be very dangerous. Now, if I have to always send a job to the cloud, and the cloud will send it to a cloud data center located in another country, okay, to execute it and then send it back to me. In reality, I don't see it as a delay, right? Because it's so fast. But then there are now new devices whereby they are very sensitive to delay. Okay, I'll give you an example. Since we are moving to IoT devices, Internet of Vehicles coming in, the chances are even our traffic lights, for example, will have to be connected to the internet. Okay, and in the traffic situation, a little bit of delay can actually cause traffic jams or even cause accidents, right? So in this case, we will need basically the cloud services to be very fast as possible. But because the computing device that will have to handle these cloud traffic services are not actually located here, it means that a number of processes has to go through before processing will take place and we get our jobs back. Okay, so now take example of a moving vehicle that's automated. A moving vehicle that is automated, once it's connected to the internet and connected to cloud services, it means that if it is processing its map from the cloud service, delay cannot be allowed. Do you understand? If we have automated vehicles, okay, driverless vehicles, like Tesla, driverless vehicles, and they have to be connected to the cloud because actually storage power and processing power now all depend on the cloud. Okay, otherwise over time, no matter how much processor you include, it may not be enough. Okay, so since the driverless car have to communicate with the cloud service for processing of a lot of other things, it means that we want it to be done as fast as possible, right? And if the cloud service can cause a little bit, a little delay in this situation, it can lead to a disaster, basically. So now the idea of edge computing is that we are going to have some edge devices that will actually carry out this processing without sending it to the cloud. Now, the edge devices can do any processing that we need and still give us feedback, and then keep the record and be updating it to the cloud. So edge computing is not actually completely out of the cloud. It is still working in tandem with the cloud, except that because we need more speed, as a result of the type of devices that are used these days, we try to do the computing at the edge rather than at the cloud. The edge is a computing device basically that gives us faster speed, more response time, and basically it avoids delays and also gives more security to the user, because of course cloud have issue of security. Okay, so if you are computing at the edge, a computing edge device, it means that it will be faster in terms of security. It gives you a little bit more of security because it's not completely connected to the cloud. So your data is not sent immediately to the cloud, except after a period of time, the edge device will update it to the cloud. Okay, because of course the edge device do not also have the capacity. It's an emergency situation. Let me just say this. Okay, it doesn't have the capacity of a cloud to hold large storage, large processing like the cloud, but at least it gives faster period of computation and responses. So that's the idea of edge computing.
So the edge computing, Professor, will be using the cloud only for storage and documentation, let's say.
Exactly. I mostly like to explain this in a diagram, okay? Because explaining this in verbally can be like
Same the one
to look like
they are using in aircraft, monitoring the aircraft. Of course, they have edge devices. Am I right, Professor? The one who is sitting and monitoring the airplanes goes and come from the screen.
Control tower.
control tower.
Yes,
Yes. In this case of control tower,
they have edge.
yes, if you have control tower that needs to be connected to the cloud for any service, now this is another very sensitive area, you know. So that means that you will need to have 8 devices to do your computation. So actually, as time goes on, okay, so this is the idea. Let me go back again to the screen. Okay, you can see that edge computing is actually an architecture that it integrates networking, computing, storage, controls, and application on the edge nodes. Okay, the reason is simple. They are trying to like meet timelessness requirements. Do you understand? Time requirements. Basically, in the case of cloud, there is actually some delays, but of course we don't really feel because we are not sensitive to delay. Okay, but development is now taking us to devices that are very sensitive to delay, for which if we allow delay, it can actually lead to disaster. So we need devices that can actually be able to do our competition uh, very fast, faster than what we have with the cloud. So that's how edge devices are actually. So I'm trying to like look for a diagram.
It's in Professor also the
Sorry, let me use this. Let me use this. So basically, this is the cloud. Okay, this is cloud. Okay, so for example, you have a driverless car. A driverless car to be able to send signals to the cloud and receive response may actually take longer time. Okay, so now we now have to create what is called edge devices. Okay, so edge computing is basically based on edge devices. So they perform the same function with cloud, except that now another issue with the cloud is it receives a lot of traffic from multiple people around the world. And in terms of scheduling, that means that it may also result in delay. You understand? So now each device can actually do the same thing that the cloud is required to do for you. But because it's not on the cloud, it's closer to the user than the cloud. Okay, so an edge device can be able to do any computation that is required for you and give you the right responses within the shortest period of time. But then it will be able to keep the record for a number of time and be updating it to the clouds later. That's the idea of an edge device. Okay, edge computing. Anything that has to do with edge computing, basically, this is it. Okay, it's just a node. When we say a node of a cloud, let me go back. This is just a node of a cloud. Okay, it's a node that will basically be closer to the devices that we have now and performs the same function like the cloud, but at a faster time. And then, of course, it will keep records of that with the cloud. So in terms of intelligence and data into aggregation and security, these are the reasons why we need the edge device. So for a normal user, you may think that actually an edge device maybe is not necessary because speed is not your issue. But actually, if you look at the type of devices that are coming up now, there is need to improve this edge computing technology. Okay, so in terms of real-time services, yes, it's far better than what we can have in a cloud. So like in an edge device, if you want to do a computation that will take you 10 milliseconds in an edge, in cloud it will take you 100 milliseconds. Yes. Okay, so it's like to see we have an immigration office. It handles all the immigration requirements in Qatar. And everybody is going there for visa application, for whatever. But then maybe you will have an emergency. And probably going to that immigration office to be able to do that job in a short period of time and still meet the emergency that you want to go to in the UK, it may cause delay if you go to the central immigration office that you have. Now, the immigration office decided to say, let's create additional nodes. Do you understand? So the additional nodes basically are smaller immigration offices. Now, this is the edge device now. Okay, the central one is the cloud service. The created smaller offices can handle emergencies. You go there, you do your stuff immediately, and you leave. But then if you leave, they aren't going to keep your documents there. They still have to update to the central point. So now this is the idea. You understand? The reason why we have to create edge is simply because of time. We need speed. Yeah. So actually, in terms of speed, this is the most important aspect. Optimization, data optimization, aggregation of data, of course, it can aggregate data. Again, the edge device also can handle jobs, not only one edge, many edges can actually handle jobs, okay, and then aggregate the data later. So this is another very smart way. In terms of smart intelligence, is also very smart, okay, and of course, in terms of security and privacy, is also very good in terms of security and privacy, because basically everybody will target the cloud, but if your data remain in the edge, it keeps it safe until, of course, it goes to the cloud. So this is also very good. So that's how the edge devices, actually edge computing is. So we have what is called intelligent edge. Okay, so Huawei also, they try to buy into this idea. They created their own edge, which is called edge fabric, intelligent edge fabric. Okay, so basically they also try to create edges which are connected to the cloud, which are strong and flexible. Of course, any company that is serious, when they look at all these capabilities, they need to, of course, buy into all these ideas. So cloud and edge, they have to work in synergy. Okay, they have to work in synergy. So we have the Huawei cloud, the third-party application, and then we have the Huawei clouds that works together with some AI stuffs. So this is how the edge computing basically works. Edge fabric is the one that actually works together with this. So basically what they do is that they have the Huawei cloud here, and then they have the Huawei edge here. Okay, so and then the intelligent edge fabric is basically the mechanism that communicates between the cloud and the edge. And of course, edge device users that need faster computation and stuff like that, they will have to communicate through the edge. So you have communication and any type of computation like video and audio analysis and stuff like that. You can do it on the edge, and the edge will be updated in the cloud through the intelligent edge fabric mechanisms that they created, basically. So that's how the idea works. Now, what are the features of an edge computing technology? Data upload faster. Capability development on the edge, okay, because it uses some AI capabilities and stuff like that. And also uploading from the cloud to the edge services. So this is another very important feature. Then that's what we call intelligent localization. It's sensitive to location, basically. And edge hardware acceleration is another capability of the edge device or intelligent edge device. So these are the features that we can have from edge. So it's actually three-dimensional. You can do public, private, and hybrid cloud on it, and then it has full stack hardware and full stack software capabilities. So this is why it's called three-dimensional AI. Any question? I think we have to stop here.
We have to start.
We only took 12 pages slides, I mean. But we are going to another interesting aspect, blockchain technology.
We have to be focusing.
We have to